All right, we're back, and let me go ahead and give Burak, right? Burak, you're up. Yep, okay. Burak, giving you presentation control. Okay, so Burak, you have control now, so you can go ahead and whenever you're ready to start.
Okay, so can you see my screen and is my voice clear now?
Yes, on both counts.
Okay, so hi everyone, my name is Burak Keskin and I'm a master student. I'm in my second term. For my research subject, I have chose computerized adaptive testing. So what is computerized adaptive testing, or in short CAT? It's a test administered by a computer that adjusts itself according to the threat level of each examinee. So in these tests, participants' responses to earlier questions determine what will be the next question. If an examinee answers the question correctly, the next question will be more complicated. Otherwise, it will be easier. So TOEFL or graduate record examinations are the famous examples of the exams using CAT. Generally, in computerized adaptive testing, we have a question bank, and that bank includes a large number of questions with different difficulty levels, and we select questions from it. But the key point here is the quality of each question should be verified. So in order to verify those quality of the questions, suggested method is to use item response theory. But first, we need to look at classical test theory before going in item response theory. So classical test theory is the standard method that we are having our exams. It assumes that there is an observed score, a true score, and a random score. So, for example, let's assume we know that the 70% of all the material covered in the statistics course. So this is considered as our true score. A perfect end of semester test, which doesn't exist, should ideally reflect this true score. So we should get 70, for example, as a note. But in reality, there is an error margin. So we are likely to score 65 or 75, for example, if we have an error margin of 5%. Hypothetically, if we took the test an infinite number of times, the same test, our observed score should be equal to our true score. Item response theory, this is the important part for computerized adaptive testing. It's a family of mathematical models that describe how people interact with questions, but we should make some assumptions before doing those calculations. So first assumption is the monotonicity. We assume that threat level or ability level is increasing according to the correct responses. Unidimensionality, the model, our model, that in our model, there is one dominant trait that is being measured, and this trait is the driving force for responses of the examinee. For example, this trait can be the time, response time of the examinee to answer those questions, or when the text mining comes into subject, the context of the answer, local independence. Responses given to different questions are independent of each other, so they actually change the outcome, score, and the next question, but they are independent from each other in their own context. So the last one is invariance. So it is possible to estimate thousands of questions by looking at the positions in the question response curve. So this is an example response curve. The ability of a person is measured in a value called theta. It's, in simple terms, is the probability of endorsing the correct answer for a question. So higher the individual's ability, the higher the probability of a correct response. So in this curve, for example, higher theta means there are more high ability students in that test. So if it is closer to theta value 4, it is good. So we have different parameters in item response theory. So the first parameter is item difficulty, which is shown as BI. It is a parameter that determines which questions behave along the ability scale. So on an item characteristic curve, like you see in the example, items that are difficult to endorse are shifted to the right of the scale, since students with high theta value, high ability, will answer harder questions more easily and correctly. So the second parameter is item discrimination, and it determines the rate at which the probability of a correct item changes given ability level. So what does that mean? That means for a harder question, even if you are a low ability student, you can just guess the right answer by simply just guessing, actually. In this case, there is negative discrimination. So to prevent this case, negative discrimination should be checked because discrimination of the questions should increase according to the ability level. So we cannot say that people with low ability knew the harder question. So he or she may be a higher potential we missed it. There is no such thing. And the last parameter is the guessing parameter. Item guessing is the third parameter, as I have said. So this parameter restricts the probability of the correct response as the ability approaches minus negative infinite. So I have explained that, actually. No need to explain it again. So we have three logistic models used in item response theory. The first one uses only one parameter, and it just looks at theta value in here. So the important parameter is the BI value. Second parameter, two-parameter logistic model uses two parameters, just adds the discrimination parameter. And the third parameter uses all of the parameters in item response theory and provides a result according to that. So when we compare classical test theory and item response theory, so in classical test theory, the test is the unit of analysis, but in item response theory, the question is the unit of analysis. So in classical test theory, you look at test and the test result to order the students according to their success levels. But in item response theory, you look at the questions they answer and how they answer the questions, and you order the students according to that. So in classical testing, more items are more reliable, but in item response theory, shorter items are enough to compare students and score their ability. So in classical testing, comparing scores from different measures can only be done using the test forms are parallel when test forms are parallel. But in item response, different measures can be compared as long as they are measuring the same latent rate. So properties depend on a representative sample, like you need to consider the previous exams of the attendee in order to make a conclusion. But in item response theory, you don't need to have a representative sample. That exam is enough for measuring their ability level, and so on. So what are the advantages of CAT? First is efficiency. Since the questions are adapting according to the responses of the student, each student will have different number of questions in the exam, and that can reduce the examination time up to 50%, which provides massive time saving. So second one is control of measurement precision. This algorithm measures the ability level of each examinee with same degree of precision. Fairness, asking the same questions to all examinees may result in cheating, as we know in standard pen and paper tests or even in online assessments. And that may result in higher scores than their ability level. So since CAT uses different question sets for each examinee, grades are more accurate and parallel with their ability level. Security, this is related to the fairness. If everyone gets the same number of questions, those questions will be well known, and examiner with low ability may score well on the next exam. With the next exam, I mean if he or she enters the exam again, because he or she will know the answer of those questions. In CAT, there are different set of questions, so unless examiner improves the ability, will not be able to get higher score more than the ability level. And we can do retesting in CAT. If the same examiner wants to study more and get higher grade, when the retest is done, examiner will not see the same questions. So let's say we entered the exam, CAT exam, and got a grade of 60. We decided that we can get higher grade. We enter the same exam, we studied hard. The questions will not be the same. But if we are actually studied hard and that we succeed, we will get a higher score because the precision is same in all tests. So motivation, examinees with high ability score do not waste time on easy questions. With examinees with lower ability score is not discouraged by tough questions. Immediate score reporting, this is actually important. So paper and pen styled exams requires time to score all the papers. CAT instantly provides scores after the exam is finished. CAT supports different formats like audio, video, image files. So skill level is measured by not only the answers given, but also ability to understand what they observe in those formats. What are the disadvantages of CAT? We first need to explain the possible outcomes to the attendees before even the exam. An examiner may fail the test in first 10 questions if there are constantly wrong answers, or so that their ability level is too low. Another examiner may pass with 50% correct score depending on the exam. So having individual scoring may seem like administrators are using their influence to get some student pass and others fail. But since the computer is doing the examination and scoring the results, this is actually a wrong statement in the context. So we need, if we want to do the CAT in the right way, we need to have a complex software prepared by the expert people on that subject, and very high effort is required. Question exposure is another problem of CAT. we are using data banks in GET, and examiners need to practice before they enter the exam. In a large data set, we can prepare a practice exam for them, but in this exam they will have similar or maybe the same question. Possibilities are low, but they can have the same question that they will have in the actual exam. In order to prevent that, while doing the practice exam, the frequency of same type of questions are lowered when the examinee is entered the actual exam. It requires a fully equipped lab to apply the exam. However, with the COVID-19 pandemic, remote education is applied now, so online education is more applicable, and it is easier to make CAT-based online assessment tests. CAT is easy to make and provide conclusions in a multiple choice exam, but when it comes to the exams where we write down our opinions in texts, like we do in most exams, semantic analysis comes to place. Semantic analysis is a process of drawing the meaning from text. It allows computers to understand the sentences, paragraphs, or whole documents by analyzing their grammatical structure and identify relationships between them. Semantic analysis driven tools can help companies automatically extract meaningful information from unstructured data, such as emails, customer feedback, etc. How does it work? Lexical semantic plays an important role. We need to understand the relationships between words, phrasal verbs, etc. Hyponyms, specific lexical items of a generic lexical item. For example, orange is a hyponym of fruit. So orange is a fruit and there's a relation. Polysemy, a relationship between the meanings of words or phrases. Although they might be different, they share the common core meaning. In example, I read a paper and I wrote a paper. Synonyms, words that have the same sense or the same meaning as another. For example, happy, content, ecstatic, overjoyed. And antonyms, for example, happy and sad. And there is homonyms, two words that are sound the same and spelled alike, but have a different meaning. For example, orange can be considered as a color or a fruit. As we can see in the example, even there is an city in Florida that is named Orange. Same happens with the word date, which can mean either a particular day of the month, a fruit, date fruit, or a meeting, for example. In semantic analysis with machine learning, we use computers and determine which meaning is correct in the given context. How do we extract these relations? Relationships usually involve two or more entities, which can be names of people, places, or company names. These entities are connected through a category with predefined keywords, I can say, such as works at, lives in, or headquartered at. For example, in the phrase, Steve Jobs is one of the founders of Apple, which is headquartered in California, contains two different relationships. First one is Steve Jobs is the founder of Apple, and Apple is headquartered in California. We have semantic classification models in order to make our jobs easy. First classification model is topic classification, sorting our text into predefined categories based on its content. Customer service teams may find it useful to classify support tickets as a payment issue or shipping problem, for example. Sentiment analysis is to detect emotions in a text. For example, taking comments on Facebook to get a sense on how your friends feel about your post. And intent classification. Classification texts based on what customers want to do next. You can use this tag to tag sales emails as interested or not interested, and give recommendations according to those. Keyword extraction, finding relevant words and expressions in a text. For instance, we can analyze the keywords in a bunch of tweets that have been categorized as negative and detect which words or topics are mentioned most often. And last one is entity extraction, identifying named entities in a text, like names of people, places, etc. It is useful to automatically extract names of products, emails, or any other relevant data. So in conclusion, CAT is used to measure the ability level of the examinees. With the pandemic, schools started using remote education and online examination more, so there is a large data bank of questions and answers to be processed. CAT grades each examinee individually and lowers the possibility of cheating significantly. It is time-consuming to prepare the exams, and after the exam is finished, grading the papers takes even longer time. As a conclusion, to save time, accurate grading and deep analysis of the ability level of the examinees, CAT is suggested to be used in online examination. So that's for my presentation, and thank you for listening.
All right, thank you very much, Burak.
So if you have any questions, I can answer them.
So, one thing that you spoke about, so that the kind of as the test taker, takes the test, and they're given different questions from others. You might have some complaints, I would imagine, that some examinees, the term you used in your presentation, some examinees might feel that oh, this question, even though it's listed as a similar difficulty to another question that someone else got, but it's actually much harder. Do you understand what I'm saying? So yes. How would you protect against that kind of accusation? So, is there anything in the literature about that?
Actually, there is not much information about that, because even if the exam is prepared by the experts on the subject, examinees still complain about the questions, and the best possible solution for that is to completely remove the people factor in the exam and let computer do all the examination and scoring, and even giving feedback to the examinee. So it is not really possible to stop complaints about the exam, as I have stated here in this slide. We first need to explain the possible outcomes, and examinee should enter the exam knowing that they may fail the test in first 10 questions, for example. But even if they succeed in the exam, which is the important one in CAT-based exams, examiner can say that I have grade 50, I knew the half of the questions. How is that possible? And complain about it. So that's the problem. That's the main problem about CAT, actually.
Gotcha. Okay. Any other questions?
I guess not.
Yeah, I'm not okay. Not seeing anyone. So, all right. Well, let's go ahead and end this recording then. And we have one more. We'll do one more presentation today.